Greetings to the panel and to everyone. My name is Lenuk Pereira, and I'm here to present our research titled Towards an Intelligent Digital Twin Framework for Telecommunications Networks in Emerging Economies. This work represents a cognitive framework approached and anchored in specific realities of developing nations. This is developed by the Research and Development Division of Sri Lanka Telecom PLC. Onto the slides. So the image on the left, we see a gleaming smart city which is idealized with digital twins, and on the right is actually the reality for billions of people living in emerging economies. So there is resource constraints and difficult terrain alongside legacy infrastructure. In our research, we aim to bridge this readiness gap where we propose a solution designed not just for perfect networks but for real networks found in developing countries all around the world. To understand our approach, it is important to understand our position. Sri Lanka Telecom operates as the national fiber backbone and landing stations, as well as a neutral government aligned steward for national scale data. This unique position allows us to unify inputs all across telcos and utilities, making us the only operator capable of delivering such a high fidelity and country level digital twin. So as a presentation roadmap, let me guide you through how the next few minutes will be structured. So we will have a brief introduction on the global context and local gaps. Alongside that, the majority of this presentation will consist of how we proposed our framework alongside its architecture, execution strategy. After that, we will be concluding with our impact analysis. So we can jump into the problem landscape. Here we can check into the global industry shifting towards RAN, which is radio access network, open RAN, and a virtual radio access network architectures. The promise of digital twins here is immense, predicted with 30 to 50% cost reduction in open RAN integration and a 35% reduction in compliance downtime for site management. However, these global statistics often assume a level of digital maturity that emerging economies have not reached yet. So when we try to look into the South Asian reality of things, we start to see that these global promises don't really apply, and that we face some specific barriers to this. As you can see in the table, where the world seeks network and planning efficiency, we face a sort of data void due to the lack of mapping of infrastructure. Where the world sees open RAN cost savings, we see a skill gap and a high vendor lock-in, and we also face some policy voids in spectrum management that hinder efficiency. Alongside that, we are actually facing a bit of an iceberg scenario where there are some hidden barriers to progress. So these challenges actually come as the obvious challenges come out as financial costs and lack of IoT sensors, but our proposed framework is designed to tackle that what's actually below the water, the real killers of innovation, which include the skill gap and the reliance of foreign consultants, alongside a trust deficit that prevents competitive operators from sharing necessary data. As we will be training for an intelligent twin, we need to have a sense of reliability across providers. This brings us to the core of our contribution, our proposed framework. This is a cognitive federated architecture designed specifically for hybrid environments. Moving on, I will discuss about a few of our most key and crucial layers, including our physical and edge layers, where we utilize cognitive edge agents that run lightweight machine learning models locally. This creates a reflex arc where it allows for local anomaly detection without relying on any cloud infrastructure or cloud connectivity. And another thing we have to talk about is the center or the heart, which is our digital nervous system, the twin core. So maintaining a real-time representation of our assets and our topology. So I would like to take this as a moment to express that our proposed solution is fully bidirectional, and it will be a fully bidirectional twin during its operation. So we would like to now move on to the decision intelligence, which is one of the furthermost in the right layers. So we propose integrating causal inference and fuzzy logic to automate decisions. As a framework comparison, the question why we built a new framework comes to mind. So, while there are existing frameworks like RAMI 4.0 and Modular Federated, so if we come to think of it, RAMI 4.0 offers high interoperability, however, it is way too complex to integrate with local teams. And modular approaches are very flexible and very scalable, however, we cannot integrate this very steadily with our current infrastructure. Alongside this, a proposed methodology actually serves as a hybrid where we provide a structured and layerized model approach alongside the agility required to solve specific issues such as privacy or other complexities that are present within developing nations. So how we actually solved the trust and privacy issue, we can actually go back to this trust deficit issue we have across competing operators. So to solve this, we actually employed federated learning loops. As shown here, raw data will never ever leave the edge agent, where operator A or B can train their models locally and share only the gradients of all the model updates to the central global server. This allows us to build a collective intelligence without ever exposing sensitive or competitive data. So our promise comes with a phased adaptation strategy, so we can't just implement this overnight. So therefore, in phase 1, which might take 1 to 2 years, we suggest the implementation of monitoring twins, which are fully bidirectional as mentioned earlier, to visualize the network, and we can target about a 15 to 25% operational expenditure reduction even from phase 1. And with phase 2, we hope to move our twins for prediction models now that we have collected data. And in phase 3, we can fully run an autonomous system even on current levels of infrastructure. Moving on to the results section. To summarize our innovations for our proposed framework, firstly, I would like to highlight the democratized intelligence. We plan to implement model as a service directly to counter the regional skill gap. And next, we would like to go over our privacy first collaboration, where we use federated learning to overcome the trust barrier, and as to protect the sustainability, which is our third goal, we treat sustainability not just as a metric, but as a vertical level for environmental, social, and governance compliance. Moving forward, we are initiating pilot deployments in Sri Lanka, working on standardizing our interfaces and collaborating with other operators. Sandboxes act as an approval shield, allowing us to test these advanced federated models safety within governed environments. Finally, let's look at the result. Consider the 2G tower in a rural area. Without a digital twin, it can be viewed upon as a liability, a rusting asset with unknown structural integrity. With our framework, however, it can become an intelligent asset, where we can see its real-time data and we can monitor its status. So this shifts the perspective from us reflecting on it, and we can move on to predictive analysis and to reactive repairs and predictive maintenance, further bridging the gap of digital divide and efficiency. To start off the conclusion section, I would like to acknowledge Sri Lanka Telecom's Research and Development Division for their immense support in making this research possible. I would like to thank all the authors of all the research that we have referred throughout this work. In conclusion, inaction is not a neutral choice. For emerging economies, digital twins can be viewed upon as a way to manage growing complexity with limited resources. Our proposed framework provides the roadmap to turn these challenges into assets. I would like to thank everyone for listening and for your valuable time. Thank you.